All right, in the last presentation, we talked about factoring out greatest common factor and factor by grouping. And those were very procedural. You only had to worry about one thing at a time. Now we're going to get into factoring trinomials with a leading coefficient of 1. And we're going to see that this is going to increase in difficulty a little bit just because you have to think of several things at the same time. So this comes from section 5.4 of your textbook. All right, before we get into factoring, let's review some multiplication. Factoring is the exact opposite of multiplication. So let's go ahead and multiply these and then see if we can go ahead and reverse it. So for example A, if we go ahead and factor, or if we FOIL, my firsts, I get x squared. Outsides, I get 3x. Insides, I get 2x. Lasts, I get 6. If we combine our like terms, we get x squared plus 5x plus 6. All right, a couple more. Let's look at example B. If we go ahead and FOIL this, we get first is x squared. Outsides, we get negative 5x. Insides, we get negative 3x. Lasts, we get plus 15. Combine our like terms, we get x squared minus 8x plus 15. All right, and last one, if we FOIL this, we get x squared. Outsides, we get plus 2x. Insides, we get minus 7x. Lasts, we get minus 14. If we combine our like terms, we get x squared minus 5x minus 14. Okay, before I bring up our rules, let's see what we got here. So one of the first things that we have is notice that our lasts always multiply to the last number in our trinomial. Now if we look at the middle terms, we have 3 plus 2 gives me my 5. Here we have negative 3 and negative 5 give me my negative 8. And on our last one, we have negative 6 and positive 2 give me negative 5. So when we talk about this, let's go ahead and bring up our rules now. We're going to have two cases. Our firsts, because we are dealing with just an x squared as our leading term, our firsts are always going to be x and x. So now we want to look at the last number. We're not going to go to our middle number, we go to the last number. If our last number is positive, that means that we have to multiply to a positive number. And the only way you can multiply to a positive number is if the signs are the same. Now, how do I determine whether they're both positive or both negative? For that, we look at our middle term. For instance, here I have a positive 5. That tells me I want two positive numbers. Here, my middle number is negative. That tells me I want two negative numbers. Now, the middle number tells us which numbers we want to pick. So we want things that multiply to the last and combine to the middle. So since we are talking same signs, remember numbers with same signs, we add and keep the sign. So for this one, if we have same signs, we're going to pick numbers that multiply to the last digit and add to the middle term. Okay, that's our first category. Our second category, we're going to look at the last digit and we're going to determine if it's negative. In order to multiply to a negative number, you have to have different signs. -7, +2, multiply to -14. So if our result is negative, that tells me the signs are different. Now remember that when we combine numbers that have different signs, we subtract and keep the sign. So the main thing I want to focus on is keep the sign of the larger number. So the larger number will have the same sign as the middle term. Here we have a -5. I want my larger number to be negative. To figure out the numbers, we're going to pick numbers that multiply to the last digit and, because they are different signs, subtract to the middle term. All right, let's go ahead and try some examples of this and let's talk through it. Okay, for example A, we have x squared plus 5x plus 6. So the first thing I'm going to do is I'm going to put my set of parentheses. My firsts I know are x and x. The next thing I want to do is I want to pick numbers that multiply to 6. So I'm going to list out all my possible factors. I have 1 and 6 and 2 and 3. Okay, let's look at our signs. I should have done that first. To multiply to a +6, we have same signs. And to combine to a +5, I know that they are both positive. Now remember that when they are same signs, we want to think add and keep the sign, mostly add. So of my pair of numbers over here, which ones add to 5? We get the 2 and the 3. It does not matter where you put them in your parentheses. If you FOIL this out, you should get back the original problem, and you can use that as a check step. All right, let's come down to example B. Example B, I'm going to start with my parentheses. My firsts I know are x and x. Let's talk about our signs. We are multiplying to a -21. This tells me different signs. And I want my larger number to be positive. So I'm just going to put different signs in here for now. Now I want to go ahead and figure out all the things that multiply to 21. You have 1 and 21. You also have 3 and 7. If you have different signs, do we want to add or subtract to 4? Different signs, remember we subtract, keep the sign of the larger number, so we're going to go with 3 and 7. 3 and 7 subtract to 4. Now as I set up here, my larger number I want to be positive, so I'm going to put my 7 with my plus and my 3 with my minus. If you multiply this out, you will get back the original problem. All right, let's come over to C. We're going to start by setting up our parentheses. My first are both going to be t's. Let's look at our signs now. To multiply to positive 20, we have same signs. And in order for same signs to combine to a negative number, they both need to be negative. All right, let's figure out numbers that multiply to 20. We have 1 and 20, 2 and 10, 4 and 5. Since they are same signs, we want things that add to 9. So I'm going to go with my 4 and my 5. If you multiply this out, if you FOIL it, you should get back the original problem. All right, next one, let's look at example D. We have our parentheses. Now this may look a little different because it is a little different. One thing to note is you got x's and y's running around. Now just like our x squared, when we break down x squared we get x and x. We do the same thing for the y squared. So if you want, you can plug in y and y. That takes care of all of my variables, and so now we just have to worry about the numbers. So for this one, in order to multiply to negative 48, we have different signs. Again, when they are different, we want our larger number to have the same sign as the middle one. But for now, I'm just going to go ahead and put in a minus and a plus. Note, it does not matter where you put your signs on these ones. I always put my larger number in front. I always put my larger sign in front, just as an organizational tactic. But ultimately, it does not matter where you put your signs. All right, so now let's go ahead, think of things that multiply to 48. We have 1 and 48, 2 and 24, 3 and 16, 4 and 12, 6 and 8. Now, if you can just know them off the top of your head, that's okay, but the more stuff that you write down on paper, the better off you are. All right, so now I want to know which pair combines to 2. And remember that since they are different signs, we want numbers that subtract to 2. So I'm going to go with 6 and 8. We want our larger number to be negative, so I'm going to make this x minus 8y and x plus 6y. All right, example E. Let's see what we got here. We're going to set up our parentheses. Our first are x and x. We are multiplying to positive 10, tells me same signs. And both are negative. So we get minus minus. All right, now what multiplies to 10? We have 1 and 10, 2 and 5. Since they are same signs, remember that things with same signs, we add to 7. So I want to go with 2 and 5. All right, example F. All right, we start off with our parentheses. My first are going to be x and x. To multiply to negative 15, we want different signs. And I want my larger number to be negative. So I'm just going to put in different signs for now. All right, let's see here. What multiplies to 15? We get 1 and 15, 3 and 5. Since they have different signs, we want numbers that subtract to 2. We want the 3 and the 5. So I wanted my larger number to be negative, so I'm going to put x minus 5 and x plus 3. Now real fast, I forgot to put this in here when I first wrote this up. What if I give you something like x squared minus 7x plus 5? We do our parentheses. We have same signs. Both are negative. And now what multiplies to 5? Well, the only things that multiply to 5 is 1 and 5. And does that combine to 7? No, there is nothing out there that multiplies to 5 and combines to 7. So what does that mean? Well, it means a couple things. First off, this is not factorable. Now we have a special term, special word that we use when we say something cannot be factored, and it applies to polynomials as well. We refer to it as prime. This is an example of a prime polynomial. So if you get something that does not factor, then there is a possibility that it is prime. Now keep in mind, there is a difference between something doesn't factor and you can't factor it. So don't get all crazy with the prime. I had one student one semester that put prime down for every single problem on a test, and needless to say, she didn't do very well. All right, so that takes care of some basic factoring. Now, let's go ahead and talk about factor completely. Factor completely, the first thing that we want to do is, if possible, you always want to factor out a GCF. We did that in the last section, so we're going to repeat that as our first step. Our second step is going to be factor the remaining trinomial. So let's go ahead and look at some examples. If we look at example A, the first thing I notice is all of these terms have an x. So I'm going to factor out an x. X cubed, if we take away x, we're going to be left with x squared. Minus x squared, if we take away an x, we're going to be left with x. And minus 30x, if we take away an x, we're left with minus 30. All right, let's factor the trinomial now. My first are going to be x and x. Negative 30 tells me different signs. Negative x tells me the larger number is going to be negative. So now what multiplies to 30? We get 1 and 30, 2 and 15, 3 and 10, 5 and 6. Since they are different signs, we want it to subtract to 1, so we're going to work with 5 and 6. My larger number, I want it to be negative, so we get x minus 6, x plus 5. And the last thing I need to do, and this is something that you need to make sure you do when you are factoring, is make sure that you bring down the greatest common factor into your answer. All right, let's try one more. First thing I want to do is factor out a greatest common factor. And just like we saw in the last presentation, I'm going to factor out not just a 5, but I'm also going to factor out the negative. I really struggle if my leading term is negative, and so if I can factor out that negative, I do. So if we factor out negative 5, in my first term, I am left with x squared. 50 divided by negative 5 is negative 10. Bring down our x. And negative 45 divided by negative 5 is 9. All right, we go ahead and factor our trinomial. So I got my 2 sets of parentheses. I got my firsts. Positive 9 tells me same signs. Negative 10 tells me both are negative. What multiplies to 9? We get 1 and 9 and 3 and 3. Remember that since they are same signs, we want to add to 10, so we're going to go with 1 and 9. And last step, we bring down our negative 5. All right, that takes care of factor completely. The last thing we want to do is we want to talk about solving equations. So we talked about this procedure last time. First thing we want to do is we want to set equal to 0. So we want to move all terms to one side of the equation. From there, we want to factor. We want to set each factor equal to 0 and solve. All right, let's start off with a fairly simple one. Example A. All right, we got our parentheses. Make sure that you bring down the equals 0. Our firsts are going to be x and x. We want to multiply to a positive 8. That means same signs. Both are positive. All right, what multiplies to 8? We get 1 and 8, 2 and 4. We want to pick a pair. Remember that since they are same signs, we want to add to 9. So we're going to go with 1 and 8. All right, this is factored now. So now we want to set each factor equal to 0. And solve. So my first one, I can subtract 1 from both sides. I get x equals -1. Or second factor, I can subtract 8 from both sides. and we get x equals -8. If you want, you can put this in squiggly brackets, and we're just going to report the numbers -1 and -8. All right, let's come over to example B. Example B, this is a little bit of a challenging problem because first off, not only do we have to move the 24 to the other side, we need to get it in a form that makes it factorable, meaning I do want to write it x squared minus 8bx plus c, etc., etc. So for this one, the first thing we actually need to do is we need to FOIL. So I get t squared plus t minus 10t minus 10. We can combine our like terms. And now I want to set equal to 0. So I'm going to add 24 to both sides. We get t squared minus 9t plus 14 equals 0. All right, from there I can go ahead and factor it out again. So my firsts are t and t. We have a positive 14, tells me same signs. -9 tells me both are negative. Make sure we have our equals 0. All right, what multiplies to 14? We get 1 and 14, 2 and 7. We want numbers that add to 9 because they have same signs. So I'm going to go with my 2 and my 7. From there, we can set each factor equal to 0. And we solve each one of these little equations. So for the first one, we can add 2 to both sides. We get t equals 2, or second equation, I can add 7 to both sides. We get t equals 7. If you want, you can put it in set notation. You can put it in the squiggly brackets, and we get 2, 7 inside squiggly brackets. All right, last one. Example C. Okay, for this one, the first thing we want to do is we need to move all terms to one side of the equation. Now, me personally, I always like having my leading term be positive. So I'm actually going to subtract x squared, and I'm going to subtract 30x. From both sides. So we get x cubed minus x squared minus 30x equals 0. All right, we haven't talked about graphing or factoring things that are x cubed, so we must have a common factor here, and we do. So I'm going to factor out an x. If we take away x from each one of these terms, I'm left with x squared minus x minus 30. All right, we continue our factoring. My firsts are x and x. We are multiplying to -30. That tells me different signs. and I want my larger number to be negative. So now what multiplies to 30? 1 and 30, 2 and 15, 3 and 10, 5 and 6. We want ones that subtract to 1, so we're going to work with 6 and 5. And again, we want our larger number to be negative, our smaller number to be positive. We bring down our equals 0. We also want to bring down that greatest common factor. All right, from here, we want to set each factor equal to 0. So don't forget that greatest common factor, it's still at play. We get x equals 0, and that's already solved. We get x minus 6 equals 0. And our last one is x plus 5 equals 0. So x minus 6, to solve for x, we're going to add 6 to both sides. We get x equals 6. X plus 5, we're going to subtract 5 from both sides. We get x equals negative 5. So this one has 3 solutions. Don't forget the 0. We have 0, 6, and negative 5. All right, that takes care of this section. The next section is going to be the one that's going to be more challenging. There are lots of different ways to do it. The next section we're going to look at will involve a leading coefficient that is not 1. So we're going to put a number in the front and see how that changes things up. All right, for now, go ahead and do the homework, and I will see you again shortly.